What is Databricks SQL? Databricks SQL offers SQL users a platform for querying, analyzing, and visualizing data. This course demonstrates many of the tools and features available in the Databricks SQL interface. By the end of it, you'll be able to summarize fundamental concepts for using Databricks SQL effectively, identify tools and features in Databricks SQL for querying data and sharing insights, explain how Databricks SQL supports data analysis workflows that allows users to extract and share business insights. Let's get started. Databricks SQL is a Databricks environment designed with SQL analysts in mind. You can use the built-in SQL query editor to write highly performant queries directly in your organization's data lake, so you can be sure you are always working with the most complete and current information available. The drag-and-drop visualization editor and dashboarding tool allows you to easily visualize and collect query results, and your shared workspace can simplify the discovery and sharing of new insights. The Databricks SQL UI lets you use SQL commands to perform ad hoc and exploratory data analysis in your data lake, quickly develop agile dashboards to test and validate business requirements, track KPIs with automatic alerts or dashboard refresh on the latest data. In addition to issuing queries through the Databricks SQL UI, you can issue queries using your favorite BI tool. For enterprise dashboarding, you may want to connect your favorite BI tool and use Databricks SQL to power your queries for fast performance. These BI tools provide a no-code drag-and-drop interface for data analytics, enterprise-wide distributed reports and dashboards, complex interconnected dashboards for advanced parameter filtering and customization. Databricks connects to a wide variety of BI tools and even offers native connectors for some popular tools like Tableau and Power BI. When you run your query, either through Databricks SQL or a BI tool, they pass through a JDBC or ODBC driver. These drivers allow applications to access data from Databricks using SQL. Our new drivers have been re-engineered to provide lower latencies and higher data transfer speeds. Databricks SQL endpoints are shared resources to power your queries. The routing service offers scalable query routing and load balancing with predictable low latency characteristics. Spark, the software backbone of your SQL endpoints, plans and optimizes queries to be as efficient as possible and accelerate workloads on data lakes. Photon is a new vectorized query engine designed to take full advantage of a modern CPU architecture for extremely fast parallel processing of data. Delta Lake brings reliability and organization to data lakes. When you use Databricks SQL, you are querying directly on your Delta Lake. While you're getting super fast performance, you're also accessing the same up-to-date and reliable data as the rest of your team. Before we take a closer look at the Databricks SQL UI, let's look at some key vocabulary and concepts that will help you get started. Working with Databricks SQL means you'll be working with Spark. This will not change anything about the way you write queries to access data. You will continue to use SQL to query and analyze data. However, in order to start writing queries, you'll need a Databricks administrator to set up three things: a SQL endpoint, access to a data catalog, and access to a database. A Databricks SQL endpoint is a computational resource that powers your queries. Your SQL endpoint will be set up and configured for you by your Databricks Workspace admin, or possibly you will have the ability to create your own. Databricks offers two types of endpoints. Traditional classic endpoints reside in your own cloud account. The newer option, serverless endpoints, are managed by Databricks and live in the Databricks cloud accounts. Serverless endpoints simplify management and offer quicker launch times. A catalog is the first layer of Unity Catalog's three-level namespace and is used to organize your data assets. Catalogs contain databases. You'll first need access to a catalog to access any databases within the catalog. In general, you'll be querying clean and prepared data that has been organized into tables for you. A database, which in some SQL tools is referred to as a schema, is a collection of tables and forms the second layer of Unity Catalog's three-level namespace. You will also need access to the database in order to access any tables within that database. In your queries, you'll be using the catalog, database, and table name to identify the data you want. Now let's preview the Databricks SQL UI to see some of these concepts we spoke about in motion. So here we are in the landing page. We can return to this page at any time by clicking this button in the left sidebar. Below this is a persona switcher. Use this to switch to other Databricks services such as the Data Science and Engineering Workspace or Databricks Machine Learning. Use the Create button to create a new query, table, dashboard, alert, or SQL endpoint, if your administrator has permitted you to create endpoints in your workspace. The SQL editor opens up a detailed page for viewing data structures and creating and editing SQL queries. Click the Queries button to view all available queries in your organization. You can select or deselect favorites. These show up on the main landing page. Create a new query. Open and edit existing queries. Use the Dashboards button to view all available dashboards in your organization. From here, you can select or deselect favorites, create a new dashboard, or open and edit existing dashboards. Alerts are a built-in feature to help you monitor your data and be aware of when it reaches certain thresholds. You can use this tab to set new alerts or check the status of existing ones. The Data Explorer provides a view of catalogs, databases, and tables in your metastore that you have permission to work with. Click the SQL Endpoints button to access a list of all the SQL endpoints that you have access to. You can start and stop SQL endpoints, as well as access the query history associated with any of the endpoints. The Query History tab contains information about previously run queries. You can filter by user, date range, endpoint, and status. Clicking on a query will show the query details. Partner Connect expands the capabilities of your Lakehouse and makes it easy for you to discover data and analytics tools directly within the Databricks SQL. You can quickly integrate the tools you already use today with just a few clicks. Use Help to access a menu linking to product documentation, knowledge base articles, and many other helpful resources when you're stuck or want to learn more. Use the Settings button to access user settings. In Settings, you can create and revoke personal access tokens, manage general settings, and view account details. The menu option allows you to set default behavior of the left sidebar. Now that you know a bit about the Databricks SQL interface, we can go over some details about how you will be using it to query, visualize, and share data. We will start by viewing the Queries page and learning about the query editor. Once we have query results, we can create visualizations. Then, when we have a collection of visualizations, we will go over the steps for creating a dashboard you can share. When you click on the Queries tab, you'll see a list of your organization's shared queries. You can search queries by name as well as filter by favorites or by tag. Toggle this switch to enable the ability to edit multiple queries at one time. Click Create Query to create a new query. A new blank Query tab opens in the Query Editor. Before you can run queries, you must have a running SQL endpoint. Use the drop-down menu to select the one you want to use. A green checkmark indicates an endpoint that's already running. A catalog name, or list of catalogs, can be accessed in the Schema browser. Once you select a catalog, you can see the databases within that catalog. A database name, or list of databases, can also be accessed in the Schema browser. Once you select a database, you can see all the table names that you will use in your queries. If you have access to a table, you can learn about the column names and the types of data in a table. When you click on the table name, the Schema browser shows details about a table schema. You can write queries by typing in the Query Editor. The Query Editor offers autocomplete and auto-formatting options. Once your query is complete, you can run or save it for later use. Sometimes it's helpful to copy a query. Do this using the Clone option. Now let's go back to the query list to see how to manage them. When you select a query from the Queries page, you will see the results of past executions and any visualizations associated with that query. You can use the Refresh button to update results with current data. By selecting a query, you can also edit the query itself. Allow others to access your queries using query permissions, which can be managed at the individual query level. Once you have written and saved a query, click the Share button to choose who you want to share it with. Finally, you can archive the query by moving it to the trash. One of the big advantages to querying your organization's Lakehouse is that your data is routinely updated, so you're working on the most current values. In some cases, you may want to continually watch the data to be sure some values don't fall outside a certain range. Consider the following examples. You work in a retail sales organization tracking product sales and inventory. You regularly write queries to better understand the makeup of incoming orders, existing supply, and expected deliveries. You regularly monitor changes throughout the day to ensure you can respond to developing trends. Or, you work for a navigation app that delivers real-time recommendations for products and services along a traveler's route. You have dashboards set up to balance an advertiser's spend with the number of ads your company is delivering. You check the data periodically to be sure you are not exceeding anticipated values. In each of these scenarios, the stakes are high and continuous monitoring is manual. All it takes is a missed check-in to cause an expensive problem. With Databricks SQL, you can set a schedule to automatically refresh your queries and set alerts that let you know when some values fall outside of your expected range. In the Query Editor, you will find the refresh schedule is set to Never by default. Click on Never to bring up the Refresh Schedule dialog and select a refresh frequency and optional end date. Then, click OK. Click on the Alerts tab to set an alert for your query. Use the search functionality to find your query by name. Set the threshold trigger. You can choose notification preferences like how frequently you want to be notified when the threshold trigger has been reached, as well as how you want to be notified. Everyone loves a good visual, and there's no shortage of these offered by Databricks SQL. You can add one or more visualizations to any query to replace the default tabular output. Let's see how to do this now. Visualizations are tied to a specific query. Let's open a query and add a visualization. The visualization editor is a drag and drop interface for creating many types of visualizations. You can choose from many different types of visualizations. In this example, we'll choose a chart. In an attempt to make configuration easier, column selections are pre-populated with the column names in your query result, though often you'll want to override these automatic choices depending on what you're trying to visualize. As soon as you select X and Y values, you'll see a preview of your chart. Many other customization options are available. Once you save the visualization, it will always be at your fingertips when viewing the associated query. You can compile a collection of visualizations in a dashboard you can share with other members of your organization. Let's look at how to create and edit the dashboard. Navigate to the Dashboards page by clicking on the Dashboards tab. From here, you can open an existing dashboard or create a new one. When you click on a new dashboard, you will open the dashboard editor. You can add text and visualizations to dashboards. Annotate your dashboards using basic markdown. Adding a visualization will prompt you to select a query. From there, you can choose any of the visualizations tied to that query. Once you have some widgets placed into your dashboard, you can graphically rearrange and resize them as you see fit. Once you save your dashboards, it will show up in the Dashboards page and you can share it with other members of your organization. Despite all that the Databricks SQL platform has to offer, many organizations have a preferred BI tool for helping them to analyze and visualize data. Databricks provides the pieces needed to connect BI tools to use Databricks directly as a data source. Let's look at these pieces now, and we'll follow up with connecting an example tool. Some BI tools require an additional piece of software known as a driver to connect to Databricks compute resources and access data through SQL. In all cases, your BI tool will need to authenticate with Databricks compute resources to securely access data. A personal access token is a simple, secure, and easily managed credential that enables your BI tool to authenticate with Databricks on your behalf. To run queries from your BI tool, you'll also need access to a SQL endpoint to furnish the needed compute resources. BI tools will require endpoint connectivity information to connect to your endpoint. Though the requirements and overall workflow are generally similar across most tools, exact instructions to connect with BI tools does vary by tool. The Databricks documentation provides specific instructions for many popular tools, and the Partner Connect feature, built into Databricks SQL, can simplify some of these down to a few clicks. Using Tableau Desktop as an example, let's see how to connect to Databricks SQL. Having selected the desired endpoint, let's click on the Connection Details tab. Here we see a number of connection parameters. To connect our BI tool, we'll need the values for server hostname and HTTP path. Let's copy these to a temporary location. We also need a personal access token, which is conveniently linked from this page. Choosing our token parameters will generate a new token and copy this to a temporary location. Be careful, though, to treat these tokens with the same level of care as your usernames and passwords. If you suspect a token has fallen into the wrong hands, however, it's a simple task to cancel it and generate a new one. If that process wasn't simple enough, let's see how Partner Connect makes it even simpler. Partner Connect provides connectivity to some of the popular solutions in the ecosystem, with Tableau being one of them. With Partner Connect, we don't have to collect all of that connection information. Rather, it's downloaded as a single configuration file, which we then import. We would still need to install the driver and create a token though, but since we've already done that, we don't need to do it again. Partner Connect simplifies integration with partner technologies for a variety of tasks. Before starting your next project, be sure to check it out from the left sidebar. Thank you for watching, and we hope to see you back soon.